Hi everyone. In today's lesson, we're going to talk about a concept called partial fraction decomposition. But before we can do that, I want to recall a concept that we learned previously in this year. So what if I asked you to combine 7 over x plus 4 and subtract 3 over x plus 3? So I'm asking you to subtract these two fractions. So we know that in order to add or subtract fractions, we need a common denominator. So we know that this side must need an x plus 4, and whatever I do to the bottom, I do to the top. And this side needs an x plus 3. Whatever I do to the bottom, I do to the top. And then we can simplify this. So we'll distribute the 7 in. So we'll have 7x plus 21 over x plus 3 times x plus 4. And I'm technically going to make this subtraction a plus and negative, so it's easier for me to work with. And I'll distribute the negative 3. So we have plus negative 3x minus 12 over x plus 3 times x plus 4. And we know that I can add fractions once the denominators are the same. So I keep the denominator the same, x plus 3 times x plus 4, and I simply add the numerators. So 7x plus negative 3x is positive 4x, and 21 plus negative 12 is 9. And if we wanted to take this a step further to simplify, we could distribute out the denominator. So we could have 4x plus 9 equals x squared plus 7x plus 14. Plus 12. And this would be the sum of these two fractions. So the goal for today will actually be the opposite. I'm going to give you the combined fraction, and I want to ask you what it decomposed to. So what were the two fractions that I had to add together to get this sum? So let's do an example. All right, so this one says, write the partial fraction decomposition of this fraction. So this fraction should look familiar to you. It's the do now that we just did in this video. So now I want to go backwards. I want to get the two fractions that added together that gave me this. We know that 4x plus 9 over, now I'm going to factor this, add, multiply. So the numbers that add to 7 that multiply to 12 are positive 4 and positive 3. So we know that this will decompose into some number over x plus 4 plus some number over x plus 3, right? So in order to get the x plus 4 and the x plus 3 together, one of them has to have the x plus 4, the other has to have the x plus 3, so that you can find the common denominator. So that leads me to the second step. We're actually going to do that. So to make that common denominator, this would be x plus 4, and the middle side would be x plus 3. And now that the denominators are the same, we can cross them off and say, all right, now we have the numerators set equal to each other. So we have 4x plus 9 equals a times x plus 3 plus b times x plus 4. And the idea is if we can find a and b, then we can figure out what these fractions will be. So the way that we're going to do this is we're going to pick a letter that will wipe out one of these, parentheses. So we're picking a value for x. So if x was, say, negative 3, do you agree negative 3 plus 3 would give me 0, and 0 times a would go away, and then we could solve for b. So the idea here is we're going to let x equal negative 3. So by doing that, let's see what happens. We have 4 times negative 3 plus 9 equals a times negative 3 plus 3 plus b times negative 3 plus 4. So negative 4 times 3 is negative 12. Negative 12 plus 9 is negative 3. Negative 3 plus 3 is 0, so a times 0 is 0. Negative 3 plus 4 is 1, and b times 1 is b. And 0 plus b is b. So b is equal to -3. So now that we have B, we can find A. So you want to now, since we chose X over here to be -3 to wipe that one out, we want to find the next variable that will wipe this one out. So what number do I have to put in place of X that's going to make that 0? So you should be saying -4. So we're going to let X equal -4 now. Now, if you're not sure what number would wipe it out, you always can set the stuff that's inside the parentheses, so here and here. You can always set that part equal to 0 and solve. So watch, if we did x plus 3 equals 0 and solved, we would subtract 3 on both sides, and that would give me the -3 that I let x equal. Then, if you're not sure again for the other value, you can set this x plus 4 equal to 0 and solve. So we get x equals -4. So that will tell you the values that you should let it equal. So again, plug the stuff in the parentheses, set it equal to 0, and that'll always tell you. All right, so I'm going to put in -4 in for all x. So 4 times -4 plus 9 equals A times -4 plus 3 plus B times -4 plus 4. So -16 plus 9 is going to go here. So that's -7. And then -4 plus 3 is -1. So that's -A. And -4 plus 4 is 0. And B times 0 is 0. So -7 equals -A. And you can divide both sides by -1. So A is equal to 7. So from the beginning, we said that this partial fraction decomposition would be A over x plus 4 plus B over x plus 3. Well, the A value that we got was 7, so it's going to be 7 over x plus 4 plus B, which we got from the previous page, which is -3 over x plus 3. So the partial fraction decomposition, if you want to make this one sign, you would say 7 over x plus 4 minus 3 over x plus 3. And that would be your partial fraction decomposition. All right, here's one I'd actually like you guys to try on your own, and then we can go over it in class tomorrow. So take a minute, try it, pause the video, and then when you're ready, hit resume and I'll give you the answer. All right, here's what the answer should be. -1 over x minus 1 plus 3 over 3x minus 2. So that is your partial fraction decomposition for this one. If you got it right, excellent. If not, no worries. We'll go over it in class tomorrow. All right, have a good night.